Okay, we're back at it now for topic 3B. This is exponent laws part 2. You've probably been waiting on the edge of your seat for the second half of the exponent laws. So here it is. All right. So we're going to focus on part 2 on division with exponents, and then what does a negative exponent look like? What does that mean in terms of like the actual numbers and how we simplify? Okay, so to start, I'm going to look at an example here where we have some real numbers. So we've got 2 to the 4th over 2 to the 2nd. We can think of that fraction as division. We can think of it as a fraction. Either one's the same thing. Okay, so 2 to the 4th, I'm going to go ahead and expand, right? You're going to see me expand on almost every problem here that we have to simplify. So 2 to the 4th, I'm going to rewrite that as 2 times 2 times 2 times 2. That's in the numerator. On the denominator, I'm going to have 2 squared or 2 times 2. Okay. Now, this is going to ask us to think about what we know about fractions in general here. So off to the side here, I'm going to put 3 over 3. Okay, we know when we have the same number in the numerator and denominator of a fraction that simplifies to be 1, right? It doesn't necessarily like cancel out, but 3 divided by 3 is 1. Okay, so that simplifies to be 1. So I'm going to take that back over to this problem. I've got 2 over 2 right here. Okay, that's 1. 2 over 2 again, that's 1. All right, now when I multiply on the top, we've got 2 times 2, which is 2 squared. Okay, on the bottom, I've got 1 times 1, which is just 1, right? So we don't really need to write the 1 in the denominator of a fraction. I'm going to do that for simplifying purposes. So this could simplify to be 2 squared, or if we were asked to like fully multiply it out, or just 4. Okay? All right, so in a variable sense here, x to the 5th over x to the 3rd. Well, if I go to expand that out, x to the 5th, I'm going to go ahead x times x, 3, 4, x multiplied by itself 5 times. On the bottom, I've got 3 of them, x times x times x. Okay, I'm going to look to create 1. All right, anywhere I have the same thing in the numerator and the denominator, that's 1. Right, so x over x, that's 1. X over x is 1. X over x is 1 again. Right, in this problem, I have nothing left in the denominator. Right, so remember that means 1 is in the denominator. Don't really need to write it. We don't need to. On the top, I have x times x. That is x squared. So I would say that this just simplifies to be x squared. Okay, so if we think about expanding it out, think about what we could create 1 with, all right? We want to think about if we have the same number on the top and the bottom, those are all going to create 1. They would all simplify to be 1. Here I had 5 on the top, 3 on the bottom. Kind of in my head, I can think about, I'm going to create 1 3 times, right? That's the lesser number. That's how many times I'll create 1. That would leave me with 2 up on the top, or x squared. Okay, so this example here, y to the 9th over y to the 9th. Well, this one I want to think about here. I'm going to have y expanded out 9 times, okay? I'm not going to write that, all right? On the bottom, I have y expanded out 9 times again. Okay, if I have the same thing here on the top and the bottom, each one of those 9 times is going to make 1, right? I would simplify to be 1 9 different times. There wouldn't be anything left, right? On the top, I would be multiplying by 1, bottom multiplying by 1. The only thing I'd have left is just 1, okay? So, another way to think about this, if I go back to the beginning, if I look at this, it was y to the 9th over y to the 9th. That's the same thing. That's the same thing as up here when I had 3 over 3. That's just 1 because it's the same thing in the numerator and the denominator. So if I recognize that, y to the 9th over y to the 9th, we know it's the same thing. We can just say that that's 1. Okay? All right, so that is division with exponents. That's like a quotient. Okay? All right, here we've got a big table to look at, all right? So what we're going to do is each one of these I'm going to expand out, and then I'm going to look at how it's written, and we're going to look for a pattern here. So this is how we're going to develop what does it mean to have an exponent of 0, and what does it mean to have an exponent that's negative, okay? So 2 to the 4th, that's 2 times 2 times 2 times 2. Okay, and if I were to actually like solve that, 2 times 2 is 4, times 2 is 8, times another 2, that's 16. Okay, 2 to the 3rd, 2 times 2 times 2, that is 2 times 2 is 4, times 2 is 8. Okay, 2 to the 2nd, 2 times 2, which is just 4. 2 to the 1st, that's easy, it's just one of them, so that's just 2. All right, 2 to the 0, I don't know what that is. We haven't done that before yet, all right? So what I want to do, I'm going to look for a pattern over here on this 3rd column, all right? So looking for a pattern. To go from 16 to 8, okay, in the table, we know that's subtracting 8 or it's dividing by 2. So it could be either one of those patterns. If I continue on, to go from 8 to 4, subtracting 4, dividing by 2, well, dividing by 2 seems like a constant thing. To go from 4 to 2, also dividing by 2. So it looks like in the table here, you divide by 2 as you go down each row, which makes sense, right? This is powers of 2, so going up, we would expect it to multiply by 2 each time. Okay, so to go down the table, we divide by 2. All right, I'm going to go ahead, and if that's the case, if the table should continue to divide by 2, I'm going to fill in the rest of this column here and see what that looks like. Okay, so here, this is going to be 2 divided by 2 is 1. Okay, 2 divided by 2 again, that's 0.5. Okay, divided by 2 is 0.25, and then 0.25 divided by 2 is 0.125, okay? All right, now, I don't really like decimals here, right? So I'm going to see, is there another way that we could kind of write those as a fraction? Because I know sometimes you guys prefer decimals, but we get nasty decimals sometimes, and a fraction is a lot better to work with, okay? So, looking at some of these, 0.5, I know as a decimal that's 1/2. Okay, 0.25, or as a fraction. As a fraction, 0.25 is 1/4. Okay, as a fraction, 0.125, that's 1/8. Okay, this 1 2 to the 0 is kind of a special case. We'll come back to that. Okay. All right, so looking at these, I'm going to look for a pattern again here. 1/2, well, that's got 2 on the bottom. 1/4, well, I recognize the number 4 here, right? 4 up here is 2 to the second. So maybe instead of saying 1/4, I'm going to say that that's 1 over 2 to the second. Okay, and over here, when I see 1/8 down at the bottom, I recognize 8 from up in my table. That's 2 to the third. So I could say this is 1 over 2 to the third. Okay, going back to the 1/2, well, 2 is 2 to the first, right? So this is like 1 over 2 to the first power. Okay, I'm seeing a little bit of a connection here, right? I'm seeing if this was 2 to the -1 power, 2 to the first power is on the bottom of that fraction. Okay, if this was 2 to the -2nd power, 2 to the 2nd power is on the bottom of that fraction. 2 to the -3rd power, the 3rd power is on the bottom of that fraction. So it looks like when we have a negative exponent, that goes to the bottom of a fraction, and that exponent becomes positive. Okay, so kind of generalizing that, I'm going to give myself a little more space here. Generalizing that, if I have any variable taken to a negative exponent, say x to the -3rd. Okay, following this pattern here, well, -3rd power, it was the same power on the bottom of a fraction being positive. So I could rewrite this as 1 over x to the +3rd, all right? We always want to deal with positive exponents because those we can evaluate. I could find x to the 3rd and then just write it as a fraction. Okay, similarly, if I had, let's go bigger, p to the -7th. Okay, I see a negative exponent. My pattern tells me that's going to go to the bottom of a fraction, so 1 over p to the 7th power, and then it's positive. Okay, if I use a number, if I have 4 to the -2nd, okay, that would go to the bottom of a fraction. 4 to the 2nd would go on the bottom. I know 4 to the 2nd is 16, so I could say this is 1 over 16. Okay, so negative exponents, we stick them on the bottom of a fraction. That's how they become positive. It's like an inverse. Okay, the other thing I see here, this 0 exponent, 2 to the 0 power turned out to be 1. Okay, that's another kind of just thing we want to know about exponents. If you take your calculator and test this, and you should do this just to verify, don't just believe me. If you punch in any number to the 0 power, it's always going to be 1. All right, those are the easiest problems in the world. You should thank me for giving you those on an assessment. All right, if I ask you any number to a 0 power, if I say x to the 0 power, you just say, hey, I found out in this table here the pattern is for a 0 exponent, it's 1. Can't fool with me, Miss Whiteside, I know that. Okay, anything to the 0 power, we're always going to simplify to be 1. So I could make up this crazy, really long problem here. I could say, we could go like z to the 3rd times y to the 5th over x to the -7th power times z. Again, and if I said that whole thing is to the 0 power, you're like, nope, too easy. Anything to the 0 power is 1. Okay, so that's another kind of exponent thing that we want to pay attention to. If we have something with 0 power, it's just 1. Okay, all right, so looking at using some of this, we're getting to the end of our video here. I don't want to run too long. All right, we're going to simplify y to the 5th over y to the 8th. Okay, so I'm going to think about expanding this out. Okay, y to the 5th over y to the 8th. Well, this is, I've got 5 y's on the top. Why is my thing moving there? Okay, y times y times y times y times y on the top. Y to the 8th on the bottom. 4, 5, 6, 7, 8. Wow, that's a lot of y's. Okay, I'm going to look to create 1, right? That's what we're looking for. Same thing on the top and the bottom. Y over y, y over y, y over y, y over y, y over y. There we go. We're left with y, 1 times 1 times 1 times 1 times 1 on the top. Okay, all those ones just multiply to be 1. On the bottom, Well, I've got 5 ones, which doesn't change anything. 3 y's being multiplied. 3 y's would be y to the third. So this would be 1 over y to the third. Or another way that I could write that, if it asked me to, I could say that that's the same thing as y to the negative third. Remember, we just learned a negative exponent goes on the bottom of the fraction. So depending on what kind of answer we're looking for, both of these would be acceptable. Sometimes they'll say make sure your answer is written with a positive exponent. Then we would want 1 over y to the third. Okay? All right. Same thing here. This other one I want to look at, p to the fourth over p to the fifth. I'm not going to expand it. We're going to think through it. On the top, I have p multiplied 4 times. On the bottom, I have p multiplied 5 times. 4 of those are going to create 1, right? That means there's just a 1 left on the top. On the bottom, well, I have 4 1s and 1 p left, right? So 1 over p. We'd say that's just 1 over p. 1 over p to the first is the same thing, or p to the negative 1. Okay? All right, so this is the one I want you to try. Come with to class tomorrow. We've got x to the second times y to the third over x times y to the fifth. All right, try this one. Come with this one ready for us to start class with.